Okay, we're going to try to solve a problem about tangent lines. And actually this problem is similar to one from your textbook. I'll leave that one to you after you've seen an approach here. So this is a 2.4 question. It says find equations for all lines tangent to the graph of the function f of x equals x squared minus 2x and passing through the point 0, negative 4. I want to look at the graph of this first, and to do that I'm going to bring up a new Geometry Sketchpad document. I'm going to right click on the background and say plot new function. It's the second option from the bottom. I can also say graph plot new function in the menu. So I plot new function and I will graph x squared minus 2x. This function is, as you can see, a parabola that opens upward. It has two zeros at 0 and positive 2. And the other part of this question has to do with a point. So I'm going to scale this back a little bit. I'm going to draw the point on here. I'm going to plot points. So from the graph menu, I can plot points. And I'm going to plot the point 0, negative 4. We're asked to find equations for all of the lines that pass through 0, 4 and are tangent to this curve. Now, we can draw a line starting through this point 0, 4, and we need to know how many such lines are there. And as we go around, maybe we can see one. Maybe we could say there's somewhere around there must be a tangent line where here I see it intersecting the curve twice, and there it doesn't intersect at all, and maybe somewhere in there it must intersect once. And this is a fine observation to make. And likewise over here we could see that there's a place somewhere in here, and we don't find it very specifically, but somewhere there must be a place where the line is actually tangent to the curve. So we look at the graph and we expect that we'll find two such lines. Now we have to work algebraically in order to be solid about this result. So find equations for all lines tangent to the graph. Now all of the tangent lines have a slope that we can understand. We have an expression for the tangent slope. Now, in our function, we're working with the function f equals x squared minus 2x. So we're going to see that m for us is the limit as h goes to 0 of a plus h squared minus 2 times a plus h. And then we're subtracting f of a. F of a, this function at a would be a squared minus 2a. We're dividing all that by h. Now the limit as h goes to 0, we're going to need to expand some of this. So a plus h squared would be written as a squared plus 2ah plus h squared. And we're subtracting minus 2a minus 2h minus, I'll distribute this, so a squared minus plus 2a, all divided by h. After these things cancel out, we're going to have a squared and minus a squared that cancels out. We'll have 2a and minus 2a, and everything else is there to stay. So we have the next line will look like limit as h goes to 0. Everything that's left also have to take out a factor of h over h. And if we take out h, so factor out in h, we get 2a plus h minus 2. The limit of the h over h part, let me fix this a little bit. The limit of the h over h part, we can push off the side and say limit as h goes to 0 of h over h. We'll know that limit to be simply 1. The limit as h goes to 0 of the rest of it, the 2a plus h minus 2. Okay, so the first limit is 1. The second limit as h goes to 0, 2a plus h minus 2 just becomes 2a minus 2 to the h goes to 0. So we have a limit of 2a minus 2. Now that result tells us that this function up here, the slope of the curve okay, so the slope of the curve is the slope of the curve x squared minus 2x at a squared minus 2a is 2a minus 2. That's an important result because it lets us write a general form of a tangent line. So the tangent line, in fact it's all tangent lines for this function. So all tangent lines for this function pass through the point a f of a, and they have the slope 2a minus 2. So we can use the point slope form. I'll say y minus, this is the point slope form, y minus y naught equals m times x minus x naught. Now for us, the point on the curve is x equals a and y equals this other expression, y minus a squared minus 2a equals the slope. The slope is 2a minus 2 times x minus a. And this is all tangent lines. Now it could simplify a bit, and it changes according to a. So where you are on the curve, it changes. But a is the x value of the point of tangency. So in this equation, if we go back up to the question and see this passes through the point 0, negative 4. So we're getting close. We want those tangent lines which also pass through 0, negative 4. So if we put in x equals 0 and y equals negative 4, we need to also have a true equation. So when y equals negative 4, we have negative 4 minus a squared plus 2a equals, and I'm going to let x equal 0. When x equals 0, this term here is only x minus a, becomes negative a. So we will have negative 2a squared plus 2a on the right side. If I add 2a squared to this side, I would have a squared over here. The 2a's cancel out. I'll have a squared minus 4 equals 0. And from that we see that a equals plus or minus 2. Now what this means is that a equals plus or minus 2, if you recall from the beginning when we looked at the graph, a equals plus or minus 2, those are the x values of the points of tangency on this curve. So if we go back to that picture, plus 2 is this point, minus 2 is that point, and we were right. If we guessed those 2 points, that would have been correct. And more particularly, to answer our question, we need to find the 2 tangent lines which have this form, but now we know which values of a we want. So we're going to take that expression and we're going to write it again down here, and now we know that a equals plus or minus 2. So one of these equations will look like this. So these 2 lines are tangent to the curve, and they pass through the point negative 0, negative 4. And we'll go ahead and check that on our graph. If I graph those 2 lines, one of them is 2x minus 4. So I'll say plot new function 2x minus 4, and I'll take away this line that was just our estimate. The other line that we saw was negative 6x minus 4. So I'll plot the point. I'll take this away. I'll plot a new function, negative 6x minus 4. Okay, and there's the other tangent line. And so we found those 2 lines which are tangent to the curve and which pass through the point 0, negative 4. And that's the end of my problem.